Okay, we can change the direction of the current in the wire, meaning it can flow into the paper or out of the paper. And we can also change the pole of the magnet. Okay, so in this case, using the Fleming left hand rule, the index finger pointing in the direction of the field. Okay, this is the axis of the field, meaning it can only point from left to right or right to left. And then for the wire, the current can either flow out of the paper or into the paper, but it's still on this axis. So if the axis of the magnetic field and the current, they are fixed, your force can only be pointing in this axis, meaning it can either point up or down only. Okay, this is because the force must be perpendicular to the magnetic field, and it has to be perpendicular to the current as well. So in this case, we can conclude that the force can only be either upwards or downward. So there's only two directions in which the force can act. Answer B. This is a recall question. We have a DC motor in this diagram. So in order for the DC motor to be working and turning in one direction, a split ring commutator must be placed across X and Y. Answer D. In this question, the primary coil voltage is 240 volt and the number of turns on the primary coil is 1200, and we want the secondary coil voltage to be 12 volt. So how many turns must there be on the secondary coil? Using the formula, Vp over Vs is equal to Np over Ns. So Ns is equal to Np multiplied by Vs divided by Vp. So that will be 1200 multiplied by 12 divided by 240. We will get 60. So in this case, we know that the 12 volt lamp must be connected to 2 points such that the number of turns between these two points is 60 turns. So the only way that we can connect, it will be between S and U. This will be 40 plus 20 is equal to 60 turns. So the answer should be SU. The electrical power is usually transmitted at high voltage because of this reason. Let's look at the formula. Power is equal to VI. Power is constant in this case. So when the voltage increases, it will cause the current to decrease. And the power loss in the transmission cable is equal to I square R. So if the current passing through the cable is reduced, we can reduce the power loss in the transmission cable, and hence little energy will be wasted in the transmission cable. Answer A. Okay, it is stated that the horizontal scale is 5 milliseconds per cm. So one small square represents 5 milliseconds. So the time taken for the generator to turn one complete cycle, right? It will be from here, go all the way up, then go all the way down and come back to the same point. So it will cover 4 small square. That will be 4 times 5 milliseconds. We have 20 milliseconds. That is the time taken for one complete rotation. Answer C.